right. Well, it's good to be back. My name is Mike Moore. If you had Wi-Fi, you could gem install Gosu and follow along, but you can do that afterwards as well. So first off, I've had a flu for about a week, and I thought it would be over by now, and it's not. And so I was not feeling very good yesterday at all, and I caught a late night plane out. I stopped at the store and I got these like Dayquil, NyQuil, gel tabs, and then as I broke them open this morning to try and mask the effects of this cold I've got, I noticed that they were the Alka-Seltzer effervescent little tablets that you put into the water. So I put it in and I waited and I looked at the glass and I thought they were all gone, and then I just quickly downed it, but they weren't quite broken up yet, and they went all the way down my throat. So this is a very real possibility. Not just because I'm nervous, but I'm actually gassy from that. So, okay, so I have a secret. And this secret, and you guys are the first to hear this, is that writing games is fun. All right? So, show of hands, how many here like to play games on their computer or on their phones or any computing device? So that's pretty much everybody. Also, show of hands, who has ever tried to write a game before? Awesome, so about half. Ooh, good. Okay, so we're going to talk about what it takes to write games. And so if you're not familiar with writing games, then this is what you want. And if you're an old hat, then you're going to be very bored. So writing games is fun. It'll blow your mind. Okay, I think writing games is really, really fun because I like to use Ruby to write games. I find that Ruby is a much funner language to write games in than C or C++, because I get to focus on what I want it to do and not so much about how it's going to do it. So I love Ruby, and that's why writing games is fun for me. We're going to use this library called Gosu. Gosu is a minimalistic game library. It is not a framework. This is not something that you're going to open up and have a whole bunch of templates to build your game out of. There's not a lot of guidance involved. This is very much a very hands-off, minimalistic way to print to the screen and to make your sound card do sounds. That's basically it. But it's a fantastic little gem, and it's got first-class Ruby support. So it's written in C++, but it was written intended to be used within Ruby. So it's just fantastic support within Ruby. So definitely go and look that up. It's at libgosu.org. All right, so real quick, before we get into how to write games, let's talk about what is possible in writing games. So what I'm going to do, I'm going to kick out over here. So if you go to your code directory and your Gosu directory, and then if you check out the Gosu project, there's an examples directory. They have a bunch of files that you can run to get to know how it works. I'm going to switch to my Gosu gem set. Oh, here's the other thing. I cannot type in public at all. So if anybody's looking at me, even if I'm like in our same room and someone's looking at me, I can't type. So we're going to be live coding this, and this is going to be fun for me. Nobody look at me while I do this. All right, so this is one of the example programs that comes with the Gosu project, and this is Captain Ruby. Captain Ruby is a little platformer. You use your arrow keys, and you can move left and right, and as you push up, he'll jump. So, and if you don't push up at the right time, you'll fall. See if I can get up. Let's see. I can never get all the way up there. Anyway, so this is possible with Gosu. This is kind of out of the box. All right. So there's another one. I have kids, and one of the things that my kids used to want to do is always sit in my lap and to type on the keyboard with me, and that was really annoying. So what I did is I got a netbook, a little 9-inch netbook, and it was running Linux. And this is actually the first thing that I did with Gosu. I wanted them to play a game that they thought they were doing what I was doing, which was working on the computer. So I called it Little Brat. So if you gem install Little Brat, then this will come up. And then as you type, Oh, can we get the sound? There you go. So, and when my kids were 2 and 3, they thought this was fantastic. So, Control Q ends it. So that was my first one, and I loved it. So it's a gem. You just gem install Little Brat and run Little Brat, and it works, and it's really fun. Another game that I wrote is called Escape to RubyConf. So I did an earlier version of this presentation at RubyConf 2010, and this was the code that we were building up to within that presentation.
Begin.
And so this was, very 2010. So you're the code ninja here. And you're trying to avoid all the evil Python snakes here. You get to the end,
win.
And you win. Look at that.
Begin.
And then you do it again, and now you have even more. So every time you level up, you get more snakes.
Begin.
And then if you get
fail,
hit, then you fail. So, all right. And then a few weeks ago, I was at LA RubyConf, and it was when Aaron was tweeting a lot about Flappy Bird, and I was like, "Hey, that's a game." Here's my sort of Flappy Bird clone. It's called Ruby Hop. What you do is you just hop through hoops as this little Ruby guy. There you go. So I got 6. All right. So. Anyways, that's what's possible. There's a lot more things that are possible. If you get on the libgosu site, look at the forums. There's a lot of people who write lots of games. There's a competition called Ludlum Dare that is a 48-hour solo hackathon, basically, and you write an entire game as much complete as you can within 48 hours. And Gosu is a fantastic little framework, or little library, to let you do that. So let's talk about, so now we saw what was possible. Captain Ruby, Little Brat, Escape to RubyConf, and Ruby Hop. The thing is about all of these is that they're easy to write, right? They're not too difficult. And most of all, they're fun. So let's talk about how we write games. All games share one thing in common, and the thing that they share in common is that they run within a game loop. This is just a normal loop within an application. This loop is going to just run continually over and over and over and over again. There are some events that this loop will call. Every time it goes through the loop, it's going to call an update method. That is where we're going to put all of our logic. So for every frame of the game, we're going to put all of that within our update. And then after we've updated our game state, then it's going to call draw. That's when we represent our new game state and draw it to the screen, right? There's also a couple of other events for button down, button up. There's probably some mouse stuff as well, but for our purposes, we're going to consider this to be the game loop, all right? And if you've done a lot of web stuff, this is like an HTTP request, right? We're going to come in, a request comes in, we're going to handle it, we're going to render something, and we're going to push it back out in the draw, okay? This is Gosu. Gosu, like I said, is minimal. There's not a lot to it. It's just got a handful of entities. The big one is it's got a window entity, and this is important. The window entity is the thing that owns your hardware. And so we're going to have to reference this window object in all of our code. We can create images. We can either load an image from the file system, or we can create a new image by combining other images together, or by drawing text to an image. And then we can also play sounds. There are 2 types of sounds that we can play. One is a song, which is usually a sound that is intended to be looping and that is a little bit longer. We've also got a sample, and a sample is something that is going to be short-lived, and we're going to have lots of them. So like every time the Ruby guy hopped, there was a little bounce sound. That would be a sample, whereas the background music would be the song. Okay. So let's talk about Gosu window. Over here, this is on libgosu. This is the website here. Let's make this bigger so everyone can see. Here is the Ruby reference, and this is basically the RDoc. if we open the class list, you see that there's not a lot of classes that Gosu defines. The one that we care about is window. We'll also talk a little bit about image and then song and sample here for this little demo. Okay. And I'm really hoping that I can click on this and go to it. All right. Where's initialize? All right. When we initialize a new window, we have 4 values that we can pass to it. The 4th one has a default value. It's going to be the width and the height of that window, whether or not we're running in full screen, and then what that update interval is. This update interval is 1/60th of a second. Okay? We can change that to a 30th of a second or 90th or whatever rate we want our game to be running in. So let's do this. Let's create something. So I'm gonna open up this my handy editor here. And I'm going to create a brand new file. We're going to call this hello.rb. Okay? And the first thing I'm going to do is I'm going to require Gosu. I'm going to create a new class, and it's going to be called hello. We are going to inherit from Gosu window. Wandu. Okay. And then we're going to create that initialize method. Now, when I create the initialize method, I like to default my initialize to what I want it to be. So if we can go back and look at our documentation, it's width, height, full screen, and then update interval. And so what I'm going to do is I'm just going to say my width is going to be 800. My height, is going to be 600. And full screen is going to be false. And then inside my initialize method, I can just call super without an argument. That will take the arguments that were in my initialize and pass them on through. Okay? So what we need hello. So in order to say hello, we'll make the caption say hello RB on L's. All right? Now that we've written this code, let's go ahead and run it. Sorry. My editor is out of control here. Ruby hello RB. Oh, that didn't work. That didn't work because I need to create new and call show on it. And there you go. Hello RB on L's. Do you guys see that? Yay. That's terrible. You shouldn't applaud that. I hit escape or return. It's not going to do anything. I can't close it. In order to close it, I've got to click on that close button. So the first thing I'm going to want to do is I'm going to create a button down event or a button down method. And it's going to be passed an ID. And what I'm going to do is I'm going to say close if the ID equals Gosu keyboard escape. Okay. Now, the reason I do this is because if I'm going to be running this game over and over, first thing I want to do is close it. So rerun this again, I hit escape, and it closes. Okay. So remember, on our game loop, every time, 60 times a second, it's going to call update, it's going to call draw, and then every time we click a button, it's going to call button down or button up. So when we press button down, I'm going to check that button and see if it's the escape key, and if it's the escape key, then I'm just going to shut the game down, right? So for the sake of completeness, let's define our update method, which wasn't doing anything, and let's define the draw method, which also wasn't doing anything. Run it one more time. It's still not doing anything, but we can close it. All right, so let's have it do something cool. What I want is instead of having that caption say hello RB on L's, I want it to actually print RB on L's. And so I want to create an image object. And I want this image to say hello RB on L's. In order to do that, I'm going to call a method on image and get a new image from text. So I'll say Gosu image from text. Now, from text takes a handful of arguments. The first one is going to be the window object. So we're going to pass this window object around to lots of things. So I'm going to pass in self. The next argument is going to be the string that I want it to say. After that, there's also a font to use. Now, thankfully, I can just say I want to use the default font name because on every system it's going to be different. And then size is, let's make it 100. Okay. And then on draw, I'm just going to say image.draw. And I think I can pass it nothing. Let's see if that works. Nope, can't pass it nothing. Let's just pass it 0, 0, and 0. And we'll talk about what those values are. There you go. Hello, RBNLs. Yay! All right, so let's talk about where we've come from. We talked a little bit about Gosu window. There can only be one instance of Gosu window running at a time. And typically what you'll do is you'll have one loaded, and then you'll load different assets to be printed onto the screen. And this is specific to kind of like the old school way that we used to print to screens. There's usually a handle that is responsible for printing to the screen. And then there's definitely the thread that we need to coordinate with. So you can only have one, right? It's like Highlander. There can only be one instance of Gosu window. We printed hello world or hello RBNLs. We talked not much about image. We just know that there's an image class, and we called the fromText method on that, and we passed some screen coordinates to the draw when we drew it. So let's talk a little bit about what those screen coordinates are. Gosu lays out the screen where the upper left-hand corner is 0, and then the bottom right-hand corner is the height and width of the screen. Okay, so we said we wanted to draw that image at 0 coordinates, and that's why it's in the upper left-hand of the screen. We know that we are 800 by 600, so if we wanted that image to be printed in the middle of the screen, we could say, well, let's print it at 400 and 300, which would be the center. If we wanted it to be completely off the screen, we would put it at 800 by 600, because it would be drawn off to the right, bottom right. So let's center this, because I want this image to be centered. So we'll come back here. We have an x and a y coordinate. X is horizontal, and y is vertical. So let's say we want this to be at 400 and 300, right? Because we want it to be centered. Let's run that again. And it's not centered. Do you guys know why it's not centered? Yeah, because the coordinate that we're drawing the image at is also the upper left-hand corner, right? So let's say 400 minus like the image dot width, and then we'll say 300 minus the image dot height, right? Let's do that. And that doesn't work either because now we've adjusted too far the other way. All right. What we can do is we can divide that width and height by 2. Okay? So do you guys see what we're doing? We take that image, we're finding the center of the screen, and then we're slowly adjusting that image back to try and be centered halfway by however tall and wide that image is. So now if we do this, let's see, now it's centered, right? Yay! Now, I know what you're thinking. Math, right? Because it's the same thing I'm thinking. There's math involved in this. Yeah, right? Math, okay? You're not going to avoid the math involved. It's not difficult math. Most of the math that we're going to be dealing with is where things are going to be positioned, how far things are from one another, maybe what the angles are, you know. So we're talking about simple trigonometry and geometry, stuff like that. Shouldn't be too difficult. It's actually really fun. The reason why I think it's really fun is because we're using it for a good purpose. We're using it to print something onto the screen so we can have fun and delight people, right? We're not using it to be a dick, right? We're not saying you have to solve this complex problem in order to do something fun, right? All right, math. So now that we're centered, let's talk a little bit about, let's talk about what else we can do with it. So one of the things I would like to do is we're making all these calculations here about where this image is going to be placed. I would pull this out and say, this is really my x-coordinate, and say, I want x to equal that value, and then this is really a y-coordinate, so we'll say y here, and we'll say y equals this. Now, 400 we know is really window dot width divided by 2, and 300 as window dot height divided by 2. So now that we've refactored this code up just a little bit, let's run it, make sure it still works. And no, not window self. There you go. So now it's still centered. All we've done is we've just moved that calculation out from our draw method into the update method. And this is something that we want to do continually. Update is for all of the logic. Drawing is just for printing to the screen. The more time you spend in draw, the slower your drawing is going to be and the slower your game is going to feel. So what we can do here is now that we've got the center point, we could manipulate that center point just a little bit. So we could say, let's take the match math dot sign of time dot now, make that a floating point, and let's multiply this times 100. Okay? All right. Not plus equal, just plus. All right. So now, very slowly, we've added this notion of movement. Now, we're not really moving it. What we're doing is 60 times a second, we're printing a brand new image, right? So this is classical animation. This is how we do stuff in games. We just, time slice things down to a 60th of a second and move things on the screen. That gives the illusion of movement. This is called a sine, this is like a sine wave, right? And we're just moving that position based on time. The other thing, so let's make it jump up and down. So we'll add math.cosine of time.now.2f, and let's multiply that times 200. And now it's going to like hop up and down, right? So, the illusion of animation. We're slowly moving to something interesting. Okay, now that we can see something, let's talk about hearing something. Let's create a music object, and I'm going to use a Gosu song class for music. And the image I'm going to use is bubble.mp3. Gosu understands MP3, WAV, and OGG Vorbis formats. Okay? And let's go ahead and just say music.play. And this should play some Why the Lucky Stiff song. Okay? So kind of getting there, kind of feeling it. It's kind of bringing us in. That's how the music works. That's how a song works. Let's also create like a beep sound, and that's going to be a Gosu a sample. And let's call that a beep.wave. It'll also do wave files. And so what I'm going to do here is that I want to beep every time I push, I guess, space. So every time the button down is a Gosu keyboard space button, I want to play that sound. So now, I'm going to hit space bar. I don't know if you can hear that. Let's turn that music down just a little bit. We'll set the volume to being 15% volume, so we can hear that a little bit better. All right, there you go. So that's it. That's, we've talked about what the window does, how we print to the window, how we update every game loop. We can create images, we can draw images to the screen, and we can bring the user in with sounds, with musics, and also with sounds. So we're on our way to doing something really interesting. We could change this up a little bit. So if I change this to Kings of Rock, and thank you. And oh, I see. Gotcha. Thank you. Live coding, ladies and gentlemen. Yeah, this should work. Let's see if that works. I'm tempted just to leave this here for like 8 minutes. Okay, now how much time do I have, by the way? When do I end? 5 minutes? Oh, wow. All right, let's get going. All right, so let's create a new file called sprite.rb. Okay, let's require Gosu again. We're going to create a new class called, let's just call it game. You can inherit from Gosu window. Actually, let's just copy my initializer. Copy paste programmer, that's me. Game new play. What I also want to do here is I want to create a player, and we'll just call player.new, and we'll pass in self. So let's create this player class. Okay. We're going to pass in a window, and we're going to hold on to that window. Yep. All right. I've got 5 minutes. I think maybe what we'll do is we'll just open up this file and look at it because I don't have much time. All right. So what we can do is if we look at this game, this sprite game, we've got we've still got the same minimalistic setup. We're inheriting from a window. We're going to be 800 by 600 again. We're still setting that caption. And then we're creating this object, a sprite. And in this file, I called it a sprite instead of a player. And then we pass window to the sprite so that the sprite knows about the window. Same thing, when on button down, we're going to close. And then every time the game loop calls update, we're just going to call update on our sprite. And every time the game loop calls draw, we're going to call draw on the sprite. So what we've done is we've deferred all this logic out of our window object onto a sprite. And so now we can create players and enemies and levels, and they can be responsible for drawing to the screen or playing songs or sounds instead of having our main class do it. Okay? And what this sprite is going to do, a sprite is a representation of coordinates on the screen. And we want our sprite to be able to move left or right. And so here we've got this direction value here. And if we move left, we're going to switch that to left. If we move right, we're going to switch it to right. And then we've also got two different types of images. We've got an idle image and we've got a moving image, right? And this is what our idle image is going to look like. This is a sprite map. This is a big image and broken up into different coordinates. And there's very small differences between the images. But taken one after another in sequence, they give the illusion of movement. So this guy has got a gentle bob on the idle sprite map. On the move sprite map, he actually moves his sort of feet and gives you the illusion of walking. And as we move that sprite across the screen along with the animation, it looks like he is walking. So let's run that. So as we move left, he just looks like he moves left, and as he moves right, it looks like he moves right. Okay, so I'm a little bit behind. I'm going to skip ahead. Okay, so we talked about songs and samples. It's easy. I hope it's fun. Sprites are responsible for a region on the screen. They can have multiple images on the background. They determine what image to show at any one point in time. They can play music. They can also be aware of other entities within your game, like enemies and how far away they are or aren't. We talked a little bit about sprite sheets, which is the images that we use to give the illusion of animation within our games. Do you guys know what parallax is? Anybody? Okay, very little. So parallax is the illusion of having two different images, one on top of another, and as you move side to side, the images move at different speeds, and it gives you illusion of depth, even though it's just a rectangle on a screen, which is like mind-blowing and awesome. All right. Just going to let that go for a while. All right, so here's my pitch. If you're at a conference, right, like we're at a conference now, or if you're at a users group or you're at a hack fest, you should write a game because it's not difficult, right? If you can write a web app, if you can print to a browser screen, you can print to a computer screen. Everything is here. It's not difficult to do, and you can come up with stuff that's really fun. We're at a conference right now. One of the things we could do, potentially, is we could come up with what would a Ruby on Rails, game look like? And maybe it looks like this, where you have to get the Ruby guy over to this little beer.
You win.
And then you win, right? So, you're at a conference. You should write a game. So come pair with me, hang out, and we'll write a game, and it'll be the most awesome thing you've ever experienced. So thank you. My name is Mike Moore. There's the pony that you're all wondering about. And I'm going to try and coordinate a Quake 3 LAN party during this conference as well. So if you want to play Quake 3 with me, please come find me. That's it.